We'll be learning about what's called compound inequalities today. So before we kind of get into the math part of it, know that in the English language, a compound word is just two words that are put together. Not too fancy, sounds fancy. So like, for example, dog and house, and we put that together and we say doghouse. Or keyboard, basketball. Okay, so compound word is two words just strung together. So therefore, you guys, the math part of it, a compound inequality is just two inequalities that are put together. So there's two types of these compound inequalities. That's why this is called lesson number 1. We're going to do the first type today. Those are called and compound inequalities. And then next lesson, we will do the second type. Those are called or compound inequalities. Okay, so like I said, it sounds really fancy, but it's really just two inequalities that we put together into one. So if I look at this first sentence here, it says find all the numbers that are greater than 2 and they are less than 9. So I want to represent all these numbers that fall into this. So numbers bigger than 2 and less than 9. This is a compound inequality. There's an inequality I can write for the first part, an inequality I can write for the second part, and then I just string them together with the word and. So let's write the two inequalities. Numbers that are greater than 2. Well, if I just use x, I would write it like this. X is greater than 2. Numbers that are less than 9, if I use x, I would just say x is less than 9. If I want to put these together, I can really kind of do that two ways if I'm talking about an and inequality. So if I kind of write the first way up here, I could literally just like kind of write it like it looks. X is greater than 2 and x is less than 9. So that's one way to write it, just with the word and. But there's another way of writing and compound inequalities, and this is really the notation that you'll see instead of having the word and in there. They'll write it like this. So it means the same thing. So if I look at kind of part of it, because I know there's two inequalities going on here, that's what compound means. But x, I want to be bigger than 2, mouth opens towards x, and I want it to be smaller than 9. So this is another way to write that, and if I read this out loud, I would say x is between 2 and 9. That's kind of what this way of writing it means. And it makes sense because x is written between 2 and 9. Notice that the signs are both less thans. Okay, so I kind of have the signs pointing the same way. If you had the signs pointing different ways, then it wouldn't make sense. It's got to make sense. It's got to be bigger than 2, smaller than 9 to be between these two. So don't get weird with it. The sign will always point the same direction when you use this notation. If I think about where the solutions are, numbers that work for x, numbers that are actually between 2 and 9, I need to make both of these inequalities true here to find my solutions. So it's got to be bigger than 2 and it's got to be smaller than 9. There's an infinite number of solutions here, you guys. So to show the answers, all the numbers that actually satisfy this, I'm going to graph it like we've been doing. The only difference is there's two numbers that I'm focusing on instead of just one. So I'm going to put both of these numbers on the number line. And please remember that the smaller numbers always go on the left and bigger numbers go on the right on the number line. Okay? So since there's kind of two numbers I'm focusing on, I have to put circles above two different numbers, which is kind of different. I do not have the or equal to on any of these. So they're both just less thans or greater than, so there's no or equal to. So I'm going to do open circles. That means that 2 and 9 are not solutions here. If I plugged in 2, 2 is not greater than 2. Okay, so that doesn't work. If I think about the shading, because you'll have shading on these compound inequalities as well, you shade where all the answers are, and this kind of like between notation, how we wrote it here, helps me with the shading here. I want numbers that are bigger than 2, so I need to go this way, and I want numbers smaller than 9. So really I'm just talking about all the numbers in between 2 and 9. So that's where I'll shade. Now, realize there is an infinite number of solutions. So there's like tons of different decimal possibilities, like 3.4567, 3.4568. There's tons of options here on numbers that are between 2 and 9. So we graphed it, we're good, we showed the answers. All right, let's do like a real life example of how you'd use compound inequalities. So let's say you're talking about the temperature on Monday. Well, the high was 74 and the low was 51. So I could represent the temperature on Monday with a compound inequality. So that's kind of the subject here, temperature. So I'm going to use T to represent that. And I'm going to write it using this like between notation here. So put T in the middle. The temperature then fell between these 2 degrees on Monday. So I know the temperature was above 51. So mouth opens towards T. The temperature was greater than 51, but it didn't get any higher than 74. So it was less than 74. Okay, make sure the way you write it makes sense. Don't get weird with your symbols. The temperature was bigger than 51 on Monday, and the temperature was smaller than 74 on Monday. Since the low was 51, I know that at some point the temperature equaled 51. So I'm going to add the or equal to. Same thing with the high. I know that at some point the temperature was exactly 74. So I'm going to put the or equal to. Okay, so that would be like my compound and inequality. Temperature was greater than 51 and it was less than 74 all day. So if I graphed that to kind of show the range of temperatures that we were hitting, I'm going to use closed circles this time, since the temperature actually was 51 and 74 on Monday. And it ranged in between those 2 numbers all day long. So I'm going to shade between. Math in real life, don't you love it? Okay, now that's a part of this lesson, being able to write a compound inequality. A bigger part probably is being able to solve a compound inequality or get x by itself. So if I'm solving inequalities, whether it's a compound or not, these are ands, I know that to do that I have to isolate the variable, which just means get the variable alone. Okay, that part hasn't changed, but how I maybe get to the variable being alone, that maybe is going to look a little different on these. Because if you look at the problems, the variable is found in the middle. There's 2 inequality symbols, since it's compound, 2 and 1. So basically, you guys, whatever you do in the middle to get x isolated, you have to do that same thing on the left and on the right side of your compound inequality here. So here's what I mean about that. And if I were you, I strongly suggest drawing vertical lines through both of your inequality symbols, since there are 2. The goal is to isolate or get x by itself in the middle. Okay, so that's what I'm after here. Basically, I just need to get rid of that minus 5. So I know if I'm subtracting 5, I'm going to add 5 to get rid of that. Now here's what I mean about the left and the right. If I add 5 in the middle, to keep this balanced, I have to add 5 on the left and on the right. So you really add 5 in 3 different places, which is kind of weird. So if I bring down my numbers here, I add 5, bring down your signs, less than and then less than or equal to. Once x is alone in the middle, you're done. So that's the answer. So x is bigger than 1, and, I know this is an and, x is less than or equal to 8. So basically, all the numbers between 1 and 8, 8 is a solution because it can be equal, 1 is not. All of those numbers are solutions to this when I plug it in. So I'm going to show where the answers are on the graph here. So let's see, I want an open circle above 1. Okay, 1 is not a solution. 8 is though, so I'm going to do a closed circle above 8. And I want all the numbers in between. Okay. So let's practice that a few more times. Again, the goal is just to get x by itself in the middle. So like number 1, I've got a 3 in front of the x. I'm multiplying it, so I need to divide by 3 to get x alone. And whatever I do in the middle, I'm going to do that same thing on the left and the right. So that's going to give me negative 4 is less than or equal to x, less than or equal to negative 1. Once x is alone, I'm done. Okay, and then I'm going to graph it. So smaller numbers on the left, negative 4 is smaller than negative 1. So x needs to be numbers that are greater than or equal to negative 4. So the closed circle, greater than or equal to would shade to the right, and less than or equal to negative 1. So it's basically just all the numbers in between negative 4 and negative 1. All right, example 2, same thing but a few more steps to kind of get x alone in the middle. Hopefully you know that if everything is being divided by something, like this one's everything's being divided by 4, you have to start by multiplying by 4 to cancel that out. Okay, and I'm going to multiply by 4 on the right and the left. So that's going to give me negative 52. And then I just have 3x minus 1 in the middle, 20 on the right. Now it's just a 2-step inequality, so I'm going to add 1 to cancel that out. Add 1 to the left, add 1 to the right. And then my last step to get x alone in the middle would be dividing by 3. So my answer, and that should come out nicely, that's negative 17 and 7. Okay, so same thing to graph it. Let's see. It's going to be a closed circle above negative 17. One number is greater than or equal to negative 17. And I want them to be smaller than 7. So that's all the numbers in between. All right, I want you guys to try number 3. And I'm going to do the last 2. So draw my lines. Oh, yay, I get the fraction one. That's fun. So in the middle here, I'm going to move what's not connected first. I'm going to subtract 4. Get that out of there. Now, remember during the first unit, I showed you guys that I don't like 2/3 x. I don't like that. I just would prefer not to have a fraction. So I move the x on top, and I write it 2x over 3. Especially if I'm going to be forced to use one of those basic calculators on the next test, which you will, I don't want to think of that as a fraction. I just want to think of that as, oh, I'm dividing everything by 3, so I need to multiply by 3 to cancel that out. So I think if you move the x on top, you won't have as many issues with figuring out how to take care of that fraction. Because then I would just divide by 2 after that, and I'm done. So we should be good to go. Yeah. So x is between 15 and 27. Open circles. I don't want to include. I don't have the or equal to. I want all the numbers in between. Bigger than 15 and smaller than 27. It's got to be between the two numbers. Okay, example 5, and notice the little note here. Pay close attention to this last one. This one's a little different. You will see why. Goal is still the same. I want to get x alone in the middle. Okay, I have way too many people, like on the last quiz, they would add 3 to move the 3, but this is a positive 3. So to move it, you need to just subtract it. Okay, be careful there. And then the sign in front of something is connected to it. So that's negative 2x left in the middle. So be really careful. This one is different, you guys, because my last step is I have to divide by negative 2. And I know, hopefully, that if I divide or multiply when I'm solving both sides by a negative number, I have to flip the sign. In this case, since there's 2 signs, I have to flip both of them. So be aware you're going to see that. They're less thans. Now it's going to be greater than. and this one's going to be greater than or equal to. Okay, so that's a little different. If you're solving and you divide or multiply by a negative number, you have got to flip both signs. Now watch when I go to graph that. Too many people just go, oh, 5, -4. Don't do that. Smaller numbers go on the left, bigger on the right. Okay, if you flip that around, you'll flip around where all the solutions are. It'll just mess it up. But basically, I want numbers greater than or equal to -4, so it can equal -4. Number's bigger. And I want numbers that are smaller than 5. So I still shade between, and I still do my circles the same way, but you got to flip-flop the way it's written here to accurately represent on the number line. Okay, so that's and compound inequality.